Hi, and welcome back to another VC Libraries Open Code Review. Today we'll be looking at a PR from Nicole called Re-enable ASAN string annotations. This is PR 3164. So the background here is that MSVC is working hard on adding support for the address sanitizer that was originally implemented in Clang LVM. So we're taking their open source code base and applying that to MSVC. And then additionally, our containers, in particular, the most popular contiguous containers, std string and std vector, do something that is a little bit unusual compared to how users directly allocate memory. With a string or a vector, the container will allocate a big block of memory all at once, and then construct within it either characters or elements. And as more elements are pushed back or placed into the container, the originally allocated but not yet consumed memory is used to store those elements. And it's only when the container runs out of unused capacity that it needs to reallocate. And both string and vector use what's known as a geometric reallocation policy, where they'll allocate some multiple of their capacity whenever they need to grow. This is somewhat counterintuitive, but it means that pushing back into them results in amortized constant time, which you would not get if you had a naive policy of, oh, let's just allocate like plus 10 elements or something, which other libraries have had, but the STL has never suffered from. So the fact that for string and vector, the allocated memory is different from the memory that actually holds elements, or that the capacity in general can be larger than the size, poses challenges for ASAN. For address sanitizer, we would like out of bounds accesses to be detected if pointers or whatever are being dereferenced into memory that does not actually hold elements. So just because it's been allocated, if it's in that unused capacity between the end of the container size and the end of the container's actual allocated capacity, we would like that range to be considered invalid. Merely looking at what allocations the program is performing would not be sufficient to do that. So that's where these annotations come into play. There are special commands that you can give to the address sanitizer machinery. And Nicole, please jump in to correct me if I'm characterizing any of this incorrectly. There are these commands that you can give to ASAN that say, okay, I have allocated some memory, but even though that memory has been allocated, I would like you to consider it bogus for the time being. And these are what are referred to as annotations. So we've applied those to both string and vector, but then we discovered problems with the string annotation. String is an unusual container because unlike vector, it has a small string optimization where strings that are below 16 narrow characters can be stored directly within the string itself. That never happens for a vector. And additionally, string has interesting alignment properties compared to vector. It does some unusual math there. So we discovered some pretty severe problems with the ASAN string annotations and had to disable them before shipping so that it wouldn't go break users who were enabling address sanitizer. So that has been the status quo for a while. Nicole has now done the intensive investigation needed to restore these annotations and get them correct. So that's what we'll be reviewing today. So that is the background. Let me take a look at the files that are being changed here. And Alt-click to minimize everything. Okay, so we have got changes to the ASAN tests, the existing tests, so we're not adding any new tests. Then we've got product code changes, and we've got a new header being added, an internal header, STL Inc. MSVC Sanitizer Annotate Container. So the presence of a new header means that we need to follow a checklist. In the STL, we are very fond of using checklists for any complicated processes that we have to do so that we don't forget important steps. If it's useful when flying a plane, it's useful when making changes in the STL. So here is our wiki page. I fondly refer to this as hack these files because that was the name of our internal SharePoint document before we made this public. Now it's called, less excitingly, files to edit when adding or removing files. Ideally, this would all be automated. In practice, we just need to make manual edits to a bunch of different places. The most annoying part is actually automated. That's the part that Amy took care of in the MSVC internal repo, this LKG thing. So there's just a script you need to run there. But for everything else, it needs to be essentially manual. So many possible things to forget there. I will be comparing against those. Let me split these. Wow, that split is not great. Can I make that fall into a single line? Yes, I can. Okay. So new header, I'll take a look at the new header. Let's first go through, this is divided into 3 sections: edits in the GitHub repository, MSVC internal, and then VS. The VS IDE needs to be told when we're adding new extensionless headers like the upcoming print header. This is not an extensionless header because it's internal and non-standard. It ends with HTTP, so that's unapplicable. So on the GitHub side, new header means we should edit CMake lists because we need to tell the build system to copy these things. So here it is. We've got, I'm virtually certain this will work because if this were misspelled, it would not work at all. Here we go. Amy has commented that yes, there is a needed setup change. Yep, that is absolutely correct. That's called out in the document here. It's below. So we've got the new header being added here. It's in sorted order. SA comes before SY. Perfect. And that's the only edit. There's a few files where we need to make 2 edits. This is not one of them, so that's good. Next up, there's a file in our legacy MS build directory. This is not a source file. It's not separately compiled, so this is inapplicable. So next is if you add a public header that is intended to be directly consumed by users, we need to put it in this test helper, but this is an internal header. It's not intended for users. Onward header units JSON. This is used for the CS+20 header units feature. When adding headers, regardless of whether they're public or private, they should be eligible to be automatically translated with a compiler option from includes to header unit imports. So we do need to edit header units JSON. And here it's being listed. Again, it is in sorted order. Search is not picking it up because I expanded that. Yep, that's great. Okay. There will also be needed edits internally because there's a compiler test for header units. So then that's in the section below. Here we're only viewing the changes for the GitHub repo. Okay. This is not a standard public header, so no impact on the named module. Not a public header, so we don't need to test whether it can be included alone, and not a standard public header. Okay, so checklist is good for the GitHub repo. We will have to do additional validation for the MSVC internal repo when we mirror this over. Okay, so I'm going to go ahead and close that. Let's take a look briefly at what code is being extracted. Nicole mentioned that to avoid duplication between vector and string, she's lifting code out into this new internal header. That's why we've got it here. So I'm going to briefly scan to see. Okay, so some of this alternate name stuff, and then actual changes to string. Okay, and then vector. Again, the stuff that turns on the annotation, more of that alternate name stuff. Yeah, the code is either, I think not quite identical, but it's extremely similar, just sort of exchanging vector and string, or swapping them out, replacing them. So, okay, I believe that's what's being unified. So now let's take a look at the new header. Okay, so when adding a new header, I like to look at an existing header for precedent, because here we don't exactly have a checklist, but there is a certain dance that we need to follow of special macros to defend against and so forth. So vector is a good one. It's a great header. Okay, so here's vector. Let's split this side by side. Nope, that's not what I want. There we go. Okay. These 120 length lines are a little bit too long for this window. That's okay. How come I don't get a horizontal scroll bar here? That's quite annoying. Okay, so let's review this. First, let's make sure that the header name is spelled properly. It is. Okay, so we begin with a comment saying whether it's standard or internal. The idea is that tools could pick this up to distinguish between standard and internal headers. I don't actually know if they ended up doing that, but that's just our convention. This is one of the rare cases where we allow anything to occur before a banner. So this is indeed an internal header. We've got the banner for a new file, which is good. We've got the pragma once. We do not have a classic include guard. This is not conventional. Even though pragma once does supersede the include guard and can be used by itself, and we do that for like internal test headers. For all of our public headers, we define an include guard, the theory being that we can use this to detect when headers are included. It seems like a good system to follow. Interestingly, this is also not doing the usual dance of pushing and popping packing or disabling warnings. This is purely macros. We've got some declarations.
There is exactly one declaration of container or sanitizer annotate contiguous container.
Okay.
I don't know if that requires pushing and popping, but
yeah, there's also a couple declarations. Okay. There are a couple declarations of variables. Mostly, I think that I think we should have the macros, the macro defenses, the warning defenses, mostly because headers grow over time. Today we're adding stuff for sanitizing vector and string. Tomorrow it will be small vector or superstring or who knows what they add in CS+, 37 or whatever. And if we don't have those defenses, it would be very hard to notice later on that they're missing. Additionally, we should defend against things like non-compiler tools, like Qt's mock dragging this in. Unless there were an extremely good reason not to, I think we should have the usual incantations. So I will add a comment here. We should have the usual incantations for a header, including preprocessor, let's call them classic, preprocessor guards, which we conventionally have in addition to pragma once. Let's see, what else? This is not an exhaustive list, it's just a quick summary. The STL compiler preprocessor defense, the hacking warning defenses, and the new macroization defense. Even if they aren't needed now, this could be useful if code is added, moved in the future, and it also serves as a good precedent for anyone copying or imitating this setter. Okay, got all my escapes there, starter view. Okay, so pragma once, we are going to imagine the usual defenses being present. Okay. Then I don't think I need to look at vector anymore because that's really just a reference for the defenses. Okay, let's look at just the code here. So we are extracting some stuff, but first it is guarded. For my nemesis, CLR pure, which we do not activate any ASAN for, we need to ensure that CLR pure continues to compile, but it does not participate in any of our new features. So guarding here is entirely appropriate. If not defined under MCE pure, that's the macro, predefined macro is documented that indicates CLR pure. So if we're not pure, and the other thing that I'm checking for is I am currently working on changes to extend /CLR, the plain one, not pure, to more headers. So we're trying to avoid as much as possible any special code for plain CLR. And this is not caring about plain CLR, so that is good. So if we're not pure and grouped together, we are not simultaneously disabling vector and the string annotations. So if either are enabled, we want all this stuff. It's only if they are simultaneously disabled that we would not want this. Does this make sense? I think so. What would this De Morgan to? If not defined pure and either not defined vector, yeah, it doesn't read better De Morgan. It reads good. It reads comprehensibly the way that Nicole's written it. Okay, so if we're not pure and we have not simultaneously disabled both, then let's define the support machinery. I think I want to quickly check that these are the right control macros. I'm assuming that they are. The old ones were under disable vector annotation, singular, and same for string, underscore disable string annotation, singular. Okay, not too worried about typos there. We do mention vector before string. There's no real argument for sorted order. Okay, that's fine. The nice thing is that the rest of it is at least consistent vector before string. So, okay. Okay, so if we're not pure and we haven't simultaneously disabled both, then declare cool stuff. At the end, we have matching comment, Indepth, not under MCE pure, and ASAN has not been disabled. Okay, that's a reasonable summary. We have those Indepth comments so that we don't forget which Indepth pairs with what, especially because Clang format insists on indenting everything in 0. Then, if defined double underscore sanitize address, which I believe is a compiler macro, indicating that if sanitize address has been passed on the command line. I see Nicole nodding, so I've guessed that correctly. And that's matched with insert ASAN annotations. Okay. So if we are compiling with ASAN enabled, then do stuff, otherwise do nothing. Okay. Does it make sense to have these as separate tests? Yes. Otherwise, if we fuse them into a single test, that get real confusing. It seems reasonable to have multiple layers.
So, yeah, that is actually not the end of that if.
Oh, it's not.
There's a big block at the front. Yeah. And
I see. Okay.
All of the other things.
Okay, then other stuff. Okay, thanks for pointing that out.
Clang and MSVC do this differently, where MSVC defines sanitize address, Clang defines, has feature sanitize or something like that.
Okay, I see that here. Okay, yeah, line 19.
Sanitizer. And then finally, doesn't have ASAN turned on, but we're building like an internal CPP file, and therefore we need to at least make sure that the string annotations are correct.
Okay, that makes sense. So it's not a whole file thing. Okay, thanks for pointing that out. Okay, very useful. Okay, so it actually matches up here. Okay, good. That is the right macro. Okay, so if we are defining sanitize address, then okay, these look like macros that are either, if they're defined, they're active. If they're not defined, they're inactive. Okay, so we're going to activate and insert vector annotations, same for string. Otherwise, okay, here's the has feature that Nicole mentioned. If defined Clang and defined has feature, above sanitize address, below Clang. This is not 100% matching the condition, but it is okay. This is already pretty lengthy. I think that's reasonable. I won't complain about that. Then if we can use has feature on address sanitizer, then define these 4 macros, insert vector and activate vector and so forth. And then have a pragma comment linker infer ASAN libs. I think because Clang does not imply this the way that MSVC does because of sanitize address. Okay. Otherwise, okay, I like the spacing here or the new lines because this helps me keep track of what's going on with all the preprocessor stuff. Above Clang, below, if we're not Clang and we're not sanitize address, okay, then our fallbacks are if we're supposed to annotate vector, insert the vector annotations, but do not try to activate. So basically, like Nicole mentioned, mark the regions of vector that are valid or invalid, but don't actually try to terminate the program or anything if invalid accesses happen. Okay, the comments here messed up. This Indepth should be commented annotate vector this Indepth matches with annotate string. Okay. The Indepth comments here are need to be fixed. The end of comments here need to be fixed. Okay. So annotate insert, vector, vector, string, string. Okay, so once the end of comments are fixed, that's good. And then Indepth, the whole region began with sanitized address. Okay. And then, okay, these are also missing end of comments. I am going to be a stickler about end of comments here just because the preprocessor stuff is so packed together, and it's not just like a single if end if in a stream of mostly normal code. Needs the rationale, and we are a little bit flexible these days on omitting the end of comments, but I'm generally a fan of having them because as code is added to preprocessor stuff, it really helps keeping track. We've seen other code bases, we work with other code bases where they do not have the same end of discipline, and it can get quite hard to figure out, hey, you know, what region are we in here? As I just got confused. Needs end if comments. Okay, so if disable vector annotation has been defined, then undef the activate and insert. Okay, so it's a full escape hatch. Same with string. Okay, here I'm just making sure that there's no vector string swaps. If I was extremely paranoid, or if GitHub made it easier, I would be like in VS Code, if I double click one, it'll highlight lightly all occurrences of the thing. I can do that manually by searching. This is what I do if I'm very concerned about typos. Here, the macro name is short enough that I can notice typos, I believe, or like double underscores, anything like that. So I think that's good. It's a with the preprocessor, because if something's like not defined, preprocessor statements will happily run with that. Typos are much more common than with ordinary identifiers where you typo, well, you're going to get a compiler error, so you don't have to be constantly worried. Okay, so next up, now after determining the values or the definedness of insert and activate, we're going to emit some detect mismatches. This helps us make sure that everything being linked into a single binary is going to use consistent definitions of these macros. I'm very happy to see that this is being used for ASAN. This is actually a feature that I requested from the compiler back in 2010 when we were struggling with iterator debug level mismatch, and it was just not diagnosed at all by the toolset. I asked the compiler team, hey, could we have like a pragma? And we invented this scheme that was originally only for the STL's iterator debug level, but was specified in a generic way that it can be extended here, where if you send a pragma detect mismatch to the compiler front end, it emits a linker directive, which is /fail if mismatch, and it just works on a pretty simple key value system with strings. Detect mismatch takes a key and a value. These fail if mismatch directives then tell the linker, hey, if you ever see a source file or an object file with directives that set the same key to different values, then some setting is really incompatible and you should fail the link. The linker doesn't actually know anything about ASAN or iterator debug level. It just knows about these keys and values. So this is a sort of generic way, extensible way for us to ensure that inconsistent things are not linked into a single binary. Okay, so if not defined, oh, and the other thing about detect mismatch is the linker will only complain if it sees two of the same keys with different values. It will never complain if it sees one TU with a key value and another TU with nothing. So if you want to detect mismatches, you've got to have them from the beginning. Like, so for example, we can't detect mixing like VS 2008 code with 2022 because that totally predated. Of course, it'll fail to link for other reasons, does not detect mismatch. Okay, so vector, 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 string, 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 good. If we haven't defined insert vector annotation, then annotate vector is off. Okay, same for string. Okay, 0 mean off, 0 means off, and then activating. Oh, interesting. So these are being done separately. So if these are ever like really set inconsistently, we'll end up getting a detect mismatch 0 and 1 in the same TU, which is super horrible and will totally fail the link. Okay, so if you haven't turned on even just inserting the vector annotations, then you clearly want it off. If you're actually activating the vector annotations, meaning do the checks and terminate the program if you see badness, then annotate vector is definitely on. And in the middle case, if you are inserting vector annotations, but you have not activated them, then you don't have any detect mismatch. I believe this is intentional. It allows our separately compiled libs to, I see Nicole nodding, so I'm on the right track, omit the annotations to update ASAN about what region is the vector valid or not. But we're not actually performing any checking. So it's okay to mix that with something that will perform checking. That seems correct.
And
this,
and to be clear here, the reason that we can do this is because of the alternate name comments below, or the alternate name annotations below. I don't know what that is. There's a word.
Okay, they're linker directives, I think.
That thing directive. Because of these alternate
your audio is completely broken up and your video has frozen. If you can still hear me.
No, I can. Can you hear me now?
I can hear you now.
Okay, cool. So, basically, if you don't link with the address sanitizer libs, then you get the default behavior of calling a do nothing function. If you don't get those, if you don't have that, if you do link with the address sanitizer libs, then you get the actual behavior of doing something. I hope that made sense.
Yeah, I think that makes sense. I think there may be one case here that we're not detecting that. Actually, no, maybe it's not too bad. Yeah, I think this is correct in all situations. I was wondering, what about the case where you have one TU translation unit that is inserting the annotations but not activating them, and that's linked with another TU that is not even inserting the annotations? Wouldn't that lead to inconsistent annotations? But that's safe because the one that's not even inserting annotations has a detect mismatch of annotate vector 0. And it's okay if some but not all TUs are inserting the annotations, but we have forbidden anything from trying to activate them because the one that didn't bother to insert the annotations turned on the detect mismatch. So at no point can you ever mix this setting and this setting, but if you have setting in the middle that will link freely with one or the other, it just can't be used to chain them together and end up with a bad situation where some but not all TUs are annotating and then somebody's trying to activate them. So, okay, this makes sense. And I assume you're simply extracting the existing scheme that we had in string and vector, but sort of just mentally double checking it now, and this makes sense. Okay, so for activate, we got vector, 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 string, string, string. That looks good. Everybody says activate. And either one will insert a pragma comment lib for STL ASAN. We use the same support lib for either vector or string. If they're both being activated, we'll get 2 pragma comment libs. That's okay. The linker will survive. It would be more work to try to avoid that. We could have a separate preprocessor conditional that says, if defined, activate vector annotation, or defined, activate string annotation, then have the single pragma comment lib, but there shouldn't be harmful to omit 2 of them. Then the detect mismatches are different. Okay, good. Next, nice comment explaining what's going on here. Only _insert star annotation should be used from here on. So for the rest of the files, we will undef string and vector. As a nitpick, I noticed that this is not using the same order. This is saying string and then vector in sorted order. It doesn't really matter. And I guess it is the opposite of the definition order. My brain notes that, but it's not really harmful. Okay. Then we have externacy
That is
blocks.
why I put that in that order, because it was opposite to the declaration order.
Okay, push, push, pop, pop, makes sense.
Yeah.
Okay, next we have externacy blocks. We have not included anything. We haven't even included yvals core h, which the usual incantations would probably end up doing because we want at least STL compiler preprocessor. We might want to use the externacy macro here. It always expands to externacy. It's not absolutely necessary. Let me check the precedent. Do we use plain externacy blocks in STL Inc? Let's turn off this. We do. We have a macro underscore extern_c, but we do not consistently use it. We have plenty of uses of plain extern_c. Okay. The existence of that macro, I believe, dates back to when YVS_CoreH could actually survive as a C header, which we no longer support. I do wonder whether we should comment the close here of that extern_c block. Usually I feel that we do if it's big. I don't know if we have a lot of examples of big ones. It's not actually that big here. That's about the upper limit of what I would find reasonable. Yeah, everything else is so small it doesn't get a comment. Yeah, and if claim format doesn't add one, it's fine. These Indepths are at least, I know I'm nitpicking, they're at least only controlling one line and they're separated from everything else. So I don't feel that they absolutely need comments. Okay, so if def underscore insert vector annotation, we have an extern conspool ASAN vector should annotate. Similarly for string and string, that's good. Here I'm mentally checking, do we need anything for modules? We do not because it's extern_c. And I'm sure that was capturing the original code as well. Okay, next up, we do have a combined if def check. If either defined underscore insert vector annotation or defined insert string annotation, then have all this common support machinery. Okay, and this is the Indepth, I believe, that's paired with that Indepth insert ASAN annotations. Okay, so then we're going to have an extern_c declaration of a function. Okay, so going through my mental list, it's not template, it's not static, not inline, explicit for seeders only, it's not virtual, we return void, so no reason for like no discard. Always needs a calling convention cdecl, sanitizer annotate contiguous container, has some names of parameters, first end, old last, new last, all ugly, all ugly. It is not marked no except, but we might need to survive.
It is not marked.
Okay.
It's not marked no except in the address sanitizer header. And so if you included both the standard header and the actual sanitizer header, you would get no except mismatches. This is why it's not marked no except.
Okay. And extern_c will at least under EHSC assume that it will not throw exceptions, so that seems reasonable. Okay, and then a dense forest of pragmas. This is, I'm assuming, just extracting what we already had. This is the sort of stuff that is needed for it to work, so I'm not too worried about typos here. I'm just going to check the architecture conditions. We have so many architectures, it's fun. If defined underscore M ARM64 emulation compatible, then they've got these real special mingled names. elif defined under M hybrid for the chippy, older architecture. Okay. elif defined MIX86 for x86. Otherwise, for the normal-ish architectures, x64, ARM, ARM64. Okay, so we have to intercept ARM64EC and hybrid before anything else because these are overlapping. Otherwise, the classic ones, x86, x64, ARM64, these are all mutually exclusive. So the order here doesn't matter, and this is reasonable. We do this elsewhere. And then if none of those have been activated, well, you're compiling on, you know, something from the far future. So we say unknown architecture. Okay, that seems reasonable. Okay. Yep. The x64 and so forth mingling does not add anything. And we just say use the defaults. x86 adds an extra underscore for extern_c. Hybrid adds some of these pound signs. Okay, that looks good. Okay, and our validation ensures that the header ends with a new line. Okay, this looks like a good header. Okay, now let's look at maybe vector first before we get to the actual string stuff. This is essentially
I recommend XMemory first.
Recommend
XMemory first because it has a very large comment explaining exactly what's going on, and our annotations for vector were wrong in very specific weird cases.
Oh, interesting. Okay, well, let's review that then. Thank you. Okay, XMemory, which is one of our central-ish internal headers, although not the most central. This is one is included by like all of the containers. We have a struct. This camel case naming is not quite conventional for us, but it's okay-ish. Though that's new. We didn't used to have that. It should probably follow the convention. Yeah, I'll comment on that because if we want to change it later, it would be possible to change, but we should have it follow the convention now. Okay, let's see. We conventionally use ugly snake case for types and functions in the STL. Ugly camel case is used for template parameters like ran it. It's a good example of an internal type. I think vector val is the one that comes to mind, like vector val. Okay. Naming, we conventionally use ugly snake case for types and functions in the STL, like vector val. Ugly camel case is used for template parameters like ran it. Okay, so we got a struct ASAN align pointers. It's internal, so I'm mentally checking against modules. No modules impact. That's good. None of this PR should be affecting public names, so we shouldn't expect to see any changes to export. It has a couple const void stars, first and end. They are not initialized to anything, so this is an aggregate. There's no constructors. How do we use this? Do we use it in this header? No, it looks like we use that elsewhere. Let me look at some uses so I get an idea of how it's used. There's a very big explaining comment. There's one use. Oh, there's a function that returns it. Get ASAN align first end in XMemory. Okay, it returns it with braces. Okay. It seems fine as an aggregate. I don't see a need for non-static data member initializers because we never use them. If we said initialize them to null putter, that would just be dead code. It wouldn't be wrong, but there's no strong motivation. It's internal only. If this was intended for wider use, I think it might be nice to have NSDMIs, but mixing like non-null and null would be bad too. So sort of better to just not have anything there. Okay, then we have a helper function or a function. This is a pure observer, so it should definitely be no discard. It is const expr, returns a const void star. It's called clamp to end, takes a const void star mid. It's const, it's no accept. That looks good. We have an STL cert that activates only in debug mode. That the mid being passed in must be greater than or equal to first. Why is there an empty string here? Does STL cert even take a? Yeah, it takes a string. We should have a message here. Yeah.
I figured
At least a minimal one.
it's a debug. It's a debug function, or sorry, no, it's an internal function. Like, does it really need it? But that probably should have one.
Actually, the question that comes to mind is we usually use STL cert and its companion STL verify when user submitted arguments could violate preconditions of the standard. If it's something that we expect users to never activate through their own misadventures, but would only happen if the library code is logic errors, then we usually use an STL internal assert, which is only active for our code base. I know we have one for static assert. Do we have just an STL?
Yeah.
I thought we had one that was, oh, is the STL internal? It looks like STL Internal Check is the name for the runtime.
That is why I could not
yeah.
find it.
Yeah. It's like STL Internal or something or other. And we got a lot of uses of it. Yeah, I think that's what this should be. But no, hold on. What's going on here? Oh, we use enable STL Internal Check to activate the STL internal static assert, but where do we use it? Oh, yvals h uses it to activate. Okay, it becomes an STL verify. Okay, so STL internal check will always run this, but only in the test harness. There's no reason for STL cert. Okay, I will add a comment saying that that's what we want. And that one, I believe, does not take a message. It does not take a message. Okay. If this is checking for logic errors in the library implementation, such that user code passing or can't, or such that user code violating preconditions. No, let's not get into that. If this is checking for logic errors in library implementation, we should use STL Internal Check, which doesn't take a message. Okay. This is checking for logic errors in library implementation. We should use STL Internal Check, which doesn't take a message. Oh, excuse me. Okay. And then this is doing the clamping. If the provided mid pointer is strictly greater than our stored end pointer, then clamp to end. Otherwise, it is less than or equal to end. And we've already asserted that it's got to be at least first, maybe bigger. So we can just return mid. Okay. That seems reasonable. Okay, so now the big comment. Here we go. The way that ASAN shadow memory works, each 8-byte block of memory, shadow memory section, has a single byte to mark it as either poison or valid. Each section has 0 to 8 valid bytes followed by poison bytes. So, and then here's some examples for how many bytes there are. 3 valid followed by 5 poison, or 8 valid are okay, but poisons followed by valid is not. Okay, that makes sense. This function, which is being defined way below, exists to fix up first and end pointers so that one can call sanitize or annotate contiguous container. And sanitize or annotate contiguous container checks that first is aligned to an 8-byte boundary. If end is not aligned to an 8-byte boundary, sanitizer, annotate contiguous container still poisons the remaining bytes in the shadow memory section. Okay, so we're going to check that the first one snaps to 8 bytes. And if end is jagged, if it doesn't align to an 8-byte boundary, we're still at least going to poison the remaining bytes. Okay. Because of the second property, we can only mark poison up to the final aligned address before the true last. Okay, otherwise we'd poison the memory after last as well, and that doesn't belong to us. Okay. Okay, I think I understand what's going on here. For the first property, we can assume that everything before first in the shadow memory section is valid, since otherwise we couldn't mark first valid. And so we just return back the first address in first shadow memory section. Okay, and I very much like that every mention of first in its meaning of parameter is escaped by backtick, so we can use the plain word first without confusion. Okay, so here's an example. CPP code, you've got a struct with alignment of 8 cat, which has an int meow spanning bytes 0 through 4. Okay, non-inclusive. We have a char buffer 16 with no alignment requirement, and that extends through bytes 4 up through 20, non-inclusive, and then an int per occupying the end, bytes 20 through 24, non-inclusive. Okay, that looks good. It is aligned as 8. 24 is divisible by 8. Okay. As an aside, we have an undocumented compiler option D1 report single class layout, which is quite useful to view this. Let me take a little detour and show this on Compiler Explorer. Can't remember if I've mentioned it before in code reviews, but if this is ever necessary, let's use MSVC. We want compiler output. Okay, so x64, MSVC latest. Okay, so if we compile with D1 report, single class layout, and then this takes a substring of the classes you want to look at. This one is cat, so I'm going to say lowercase cat here. It prints out an ASCII art diagram. Here it's picked up a couple other things like ATL implements category attribute, which is like predefined or something. But here we get class cat. It's a 24-byte class, and it begins at offsets 0, 4, and 20 for meow, buffer, and per, just like Nicole's comments demonstrate, and no padding. So if you're ever confused or uncertain about the layout of a class, try using D1 report, single class layout, and then name of class. It's undocumented and unsupported, but we've implemented it for many years, and it's probably not going away anytime soon. Okay, so first, meow and purr are just regular data members, not container buffers, so they must be valid. Okay. Then assume we want to poison all of buffer. This would mean that in a perfect world, we want something like, okay, here's a very nice diagram with bars showing where bytes begin and end, and the bars begin on these spaces. Very nice. Okay, so meow is all valid. The buffer, okay, and these SMs are the shadow memory segments because ASAN thinks about things in 8-byte granularity. Okay, so the entire buffer is poisoned. Okay, and then however, note that by the rules above, SM3, the shadow memory, is not a valid shadow memory section. We always need the valid bytes to come before the poison bytes. Thus, the closest we can actually get to it is, oh, I see the cat noises have attracted Willow. Hi, kitty. So we can mark all of SM3 as valid. Okay, so we're sort of losing out on some checking, but this is unavoidable, where dereferencing near the end of the buffer has to be accepted because it's so close to the valid memory per. This example is extremely enlightening. Thank you for writing this up. This was obviously a ton of effort to draft, but the pictures demonstrate the complicated concepts here much better than the words can. Okay,
There was
very
an
useful.
incredible amount of trial and error that went into figuring this out, by the way.
Mhm.
This is
Mhm.
all not documented, unfortunately.
Yeah, and yeah, the result is, oh, it just crashes with some horrible, inexplicable reason rather than a nice compiler or anything. So, okay, so we call aligned equals get aligned first end with cat buffer plus 16, and we get back aligned with members first is address of cat meow. Okay, that's a plain pointer, not any sort of pointer to data member. And the end is the cat buffer plus 12, which is here, okay. Then we poison as much of buffer as we can via sanitize or annotate contiguous container, aligned first, aligned end, okay, cat buffer here, and then aligned clamp to end cat buffer plus 16. Okay. So that finds this boundary here. We are allowed to assume that address cat meow is valid, since otherwise cat buffer plus anywhere between 0 and 4 could not be valid. We cannot poison up to cat buffer plus 16, since then the address of per could not be valid. Thus, this results in the shadow memory state from the second example. Okay, and that would be this example here. Yeah, because this is clearly not the first and second example. Okay, this comment makes sense. Thank you. Okay, so now we've got a plain inline function. So it is no discard because it's only returning stuff. It's got to be inline because it's not a template. We return an ASAN aligned pointer struct, get ASAN aligned first end because it returns a first and an end. Those are the names of the members. We take first, which is a const pointer to const void. Same with last. It's no accept. Okay. We have a const expr uinputter. Static here is not necessary, but not wrong, so that's fine. Static const expr uinputter tmask is take the ASAN granularity, which is power to -1, flip the bits, so it turns off all the bits for that power of 2. Okay, and that's why we can mask it. We reinterpret first and last to uinputter t, apply the mask, and then go back to const void star. Okay, that's great. Amy, who is the tech lead on ASAN, says, for the last pointer, I think this goes back to the beginning of the current chunk instead of advancing to the beginning of the next chunk. Correct, we can't advance to the beginning of the next chunk. See the example in the comment. Okay, so we're only ever stepping things back because of the nature of the mask. Okay, good. That's going to result in nice code gen. Then we have a couple of variable templates. This code goes down to CS plus 14, so we need the inline var macro. We are partially specializing, but not explicitly specializing, so that's good. We've got this headache where if we ever explicitly specialize a variable template, that's actually bogus without actual inline variables, but partial specializations are okay. So template on class container, class default to void, because we're going to do void t sphere. Inline var context precise t container allocation minimum alignment is. So by default, we get the align of the element type, the type name container value type. Okay, but if something is valid, if we can form smashed void t, the decal type of the container allocator type minimum allocation alignment. So if the allocator has this value, this thing does not need type name anywhere because we eventually end in a value. Then we call stdmax, and here we're in XMemory, so we have that available, wrapped in parentheses to defend against macros. And what are we taking the maximum of? Either the thing that we would usually use, the align of type name container value type, but if that's tiny, like if it's just a char or something, then we're guaranteed that the allocator will at least be returning stuff aligned to 8-byte or 16-byte or whatever boundary it says. But if the element type has a huge alignment requirement, well, of course, then that is the alignment requirement we're going to use. So maximum is correct. Okay, that looks good. That's all the changes to XMemory. Okay. Let's see. So now we've got changes to string and vector, and then the tests. Okay, let's see. Got a little bit of time. Let me go through vector. Okay, so we're now going to include the support header with angle brackets. We're going to do that within the compiler preprocessor guard, but it's not conditional on language mode, and it's outside our pushback. This is the right location. Okay, so then we're lifting out all this duplicated / unified code. Yep, so this is activating the stuff, the private comment lib, the declarations, the alternate names. This is great. This was detecting the minimum allocation alignment. We just reviewed this. This has been generalized too. Previously, it took a vector and asked what its value type is. And now the stuff that's in the XMemory works with arbitrary containers, not specifically vec. And it's doing stdmax. This is returning a bool. Do you have a minimum allocation alignment? The other one just returned what the minimum allocation alignment was. Okay. And then the detect mismatch. Okay, get align first. This is being removed. Looks like some of the masking work is being moved to that helper function. So we're going to see something that replaces this, but it's not just a code extraction. Okay, so here we go.
Yeah, so that thing right there was wrong. Because basically, if you have a pointer pointing at first, this is like up in memory towards end, and this is back in memory towards 7. It would push the pointer forward so that you couldn't poison, like, let's say, the first 4 bytes of the buffer. But it turns out that's not true. We can't just push the pointer backwards because we know that this must be valid in order for this to ever possibly be valid. And so we can actually poison the first 4 bytes of the buffer now.
Okay. Through the masking.
That get aligned first end, I think is what it's called, does that, does the correct masking. So this is the old masking, and this pretty complex.
Okay, so this is actually a correctness fix. Okay, right. That's good. Okay, so goodbye get aligned first. Now we are unfancying pointers because we support fancy pointers, which are things that we obtain from an allocator that look like pointers, but are actually user-defined classes or something. So whenever you see unfancy or refancy, that's what we're dealing with. So we are taking, are we doing here? Applying annotation, which works with fancy pointers in a vector. We have to unfancy them all to raw pointers. They're just losing their trailing underscores. They're all double const, okay? And then extra parentheses here to make clang format do the right thing. If const expr, the container allocation minimum alignment for our vector is strictly greater than ASAN granularity, then we can call sanitizer annotate contiguous container without adjustments. Otherwise, we need to adjust. Okay. And here.
Greater than or equal.
Oh, greater than or equal. Okay. It looks like this comment doesn't mention that, so I will add that. Let's see. Yes, you mentioned that this should be a greater equal check. Okay, great, thank you. I actually wasn't, even though I'm a fan of checking for strict versus except equal, I didn't think to question it there, so I'm glad you did. So if the allocation minimum alignment is greater than or equal to ASAN granularity, then this adjustment is not necessary. Okay, there's some comment here about possibly removing an optimization because it's making things more complex. I'll let you decide whether that's necessary. Okay, so the old state.
That is actually not an optimization, it's a correctness thing, because when we know about the allocator, we can push it forward. We can push the anti-pointer forward instead of back. So this is actually fixed in my local branch, and I apparently forgot to push before I left for home. So
okay.
Sorry.
Okay. This is, let's see if I'm caching this correctly. Okay, how does this sound? Nicole mentioned that this is needed for correctness and is not purely an optimization. Okay. Okay, old state. Include first, exclude old last is valid. And then from old last, excluding end is poison. New state, first to new last is valid. And then new last end. So we're simply, old last was the boundary between valid and poison. We're moving that to wherever new last is. So C stood qualify, which just means global scope, sanitizer, annotate, contiguous container, first end, old last, new last, okay. Otherwise, so call the new thing. Const auto aligned is stood get ASAN align first end, give it first and end. If the struct that we're given says if align first is equal to align end, well, then there's nothing. The buffer does not end. The buffer does not end at least one shadow memory section, nothing to do. Am I misparsing this? What does end mean here? Does it mean contain?
So basically, in order to mark part of a shadow memory section as poison, we need to know that we own the final byte in that shadow memory section.
Okay. So if like you're purely within a shadow memory section, you don't contain the end of one of them. Okay, so that's what this means.
Right.
Okay.
So yeah, and so we can actually like be in the middle to another middle, and we can poison at least like the first 4 bytes. Right.
Yeah.
And
but you can't be purely within a shadow memory.
But yeah, exactly.
Yeah. Okay.
By the way,
think that
I'm
makes
going
sense.
to get a charger for my phone.
Okay. And then early return, old fixed and new fixed, clamp to end, old last and new last. Okay, so now some comments of the old state and new state. And these are all inclusive, exclusive. They're all properly uglified. Okay. That makes sense. Old fixed and aligned end were the old boundaries, and now new fixed and aligned end. Okay, so we're just moving old fixed to new fixed. Okay. Call sanitizer annotate contiguous container. Okay, more discussion here. Clamp to end handling the concern. Okay. It looks like this is resolved. That's good. Okay, that's all the changes to vector. Okay, I think I've worked up my confidence and I can now review string. Okay. String includes the support header, not guarded by compiler version or standard version. Okay, that's in the right place. We are extracting out the string annotations and we are now activating them. So we'll need to go resolve this bug, which is great. Okay. Extract out the allocation stuff. Okay. Now, if def insert string annotation, we have a helper function. We look like we're within a class here. Indeed, we are within basic string itself. Yeah, this looks like basic string itself. Okay. So, and we're in the private section. Okay. if def, because this is a defined or not macro, insert string annotation, then we're going to have a helper function here. This is a function, so we can get the alignment of the class while defining it. Because of the fun fact that a class is only complete within its member function definitions. If you're simply looking at like variables, like static data members, then it's not actually complete yet. It would be circularity if you try to check the alignment and size of the class. So it actually has to be a function. So that makes sense. That's subtle enough that it is worth a comment. I like that. So we have notice guard because it's a pure observer. This is a static context per bool, small string, always ASAN aligned. Can't be const because you're static. It's no except. Okay. So the small string is always ASAN aligned when a bunch of conditions are true. The align of ourselves, basic string, must be strictly, or sorry, must be greater than or equal to ASAN granularity. So this check is good. And the mem copy val offset modulo the ASAN granularity must be 0. Okay, so our boundary is at the right place. And let's see, this whole condition must be true. The size of value type of buff size. Oh, this is an array. I was like, index into a value type. No, this is the size of an array of buff size elements of value type. Okay. Which I guess could have been expressed as size of value type times buff size, because we don't expect any padding, but that seems reasonable. So the size of essentially our small string buffer, modulo ASAN granularity must be 0, so you've got to be evenly divisible. Or if it's not, then if the align of this size type, the align of our size type. Oh, this is looking at the x86 or x64.
Basically, the reason for all of this is because I am trying to check, one, whether it's always aligned to the, like the beginning of the buffer is always aligned on the boundary ASAN thing. That's true if the first two things are true. The second thing is checking if size doesn't get put in the shadow memory section of the buffer. So if there's padding in between, or if the buffer ends a shadow memory buffer, that's fine. Or if the padding like pads the size type out to the next shadow memory buffer, shadow memory section, that's fine. Yeah, this is a lot. It is kind of terrible, but that's basically the idea. Is so that you don't poison size type your my size accidentally.
Okay. I'm going to add a comment here. If it would be possible to add additional comments explaining what you just explained, that would be helpful, because there are a lot of conditions here, and the intention of them is less than completely obvious. So comments explaining what is the meaning of this. The meaning of each sub condition here would be very helpful. Okay, great. Okay, so now modify annotation is changing signature, context per 20, because string and vector have to be context per in CS plus 20 mode. But now instead of just taking account, we take a const size type old size, const size type new size, const no accept. Okay. This no longer just says extends, shrinks the annotator range by count. You have to explicitly tell it what was the old size and the new size. That's nice. That avoids confusion. If they were the same, hey, nothing to do, return. Otherwise, they're different. We got to do stuff. So apply annotation, my data, my putter, my data, my res, the old size and the new size. Okay, simple as can be. And then we now have a new function, context per 20, static void, remove SSO annotation, taking a const scary val ref my data, no accept. Okay. This thing is I think we mentioned in other code reviews, but basic string and vector and all the other containers have base classes to help limit the impact of their allocator. So allocator, iterator, or iterators for containers only depend on important attributes of the container and not on different allocator types. So removes annotation of the small string optimization buffer with shadow memory. This results in the ability to copy into the SSO buffer without worrying. Okay. If has CXX20, end of has CXX20. Okay, so if we are constant evaluated, which we do with a runtime check, then return, because we're not going to do any ASAN stuff, of course, and const per land. Okay. Otherwise, we're either not 20 mode, so we don't have to worry about const per string, or we are in 20, but we've determined we're at runtime. Okay, so we can proceed. So we have a couple const void star consts. My buff is my data bx buff. End is my buff plus buff size. Okay. Repeating them has no cost and aligns them nicely, so that's fine. If const per small string always ASAN aligned, then nice before after comments old state new state. From my buff to end is unknown, and now my buff to end is valid. My buff end, okay. Otherwise console aligned, call, get ASAN aligned first end. Okay. The old state, we had valid, some unknown stuff in the middle, and then valid again. And now everything's going to be valid because what's going on here? We are removing the SSO annotation. The small string isn't always ASAN aligned, so we want to just remove that annotation to say, hey, everybody's valid. Okay. Okay, that looks good. Another function, const per 20, static void. Annotate switch to large, taking scary val ref my data no accept, annotates exactly the pointer is valid because we're switching to large mode, and we're going to be storing a pointer in that union. Again, if we're in CXX20 mode, if we're constant evaluated, early return, remove any SSO annotation, and then capture my buff. Putter last is okay, this is repeating. Oh, no, this is not repeating. This says my buff is bx buff. Putter last is bx putter plus 1. And then end is using my buff plus buff size. That's correct. I'm wondering if it makes sense to group my buff and end just so that it puts the buffs together. And then the putter one is separate. It's probably not strictly necessary.
The
Okay.
idea is that my buff comes before putter last, comes before end.
Okay, the locations.
Kind of a mid pointer.
Okay. And this is doing pointer arithmetic. It's not +1 byte, it's +1 pointer worth. Okay. If const per small string always ASAN aligned, then the old state, my buff to end is valid from remove SSO annotation, which we just called. New state, from my buff to putter last is valid, but from putter last to end is poison. Okay, otherwise, console aligned is get ASAN aligned for send. The old state, again, align first, which we just got here to end is valid for remove SSO annotation. And then we're going to mark the middle as poison. Okay, because we are switching to large, so the buffer in general is poison. Okay, but the putter, of course, is fine. Okay. Line first, line end, putter last. Yeah. Intersub. Trying to think. This is an extra pointer. Does this make sense? I'm worrying about exactly where this boundary is because I'm wondering, is there a distinction between arithmetic in the byte domain and arithmetic in the pointer domain? I think I may need to look at, whoops, where's string itself? I want to go to X string. Okay, so we've got buff, I think bx. No, we don't say union that often. Okay, there's one occurrence of union. Here we go. So we've got the array of buff size value types. For a narrow string, this is 16 narrow chars, followed by a pointer, and then followed by this alias thing that oh, it's a union of all these things. And this one we can basically ignore. So it's a union of them both. Interesting. And then we've got the my size and my rows after that. Okay. So I want to split this here and here. Okay. Okay, so we've got my buff is the beginning of the string, because that the BixT union is the first element. Putter last is the address of the putter, which is also the beginning of the string, +1. So, okay, so putter last points to the byte immediately after the pointer. So if a pointer is 8 bytes, the pointer exists in the first 8 bytes, 0 through 7 index, and then blah +1 is pointing to the 8th byte, the byte at index 8, the 9th byte actually. Okay, so, and then end is bx buff plus buff size, which is the end of BixD, or an end of bx. Okay. Okay, so putter last does indeed point right beyond the putter. It doesn't point at the end of the second pointer, and there is no second pointer. It points at the end of the reach. Okay, so putter last, that is the right name for it too, because it's exclusive. Okay, so did this make, I think I'm convincing myself this is correct. New state, align first, up to putter last is valid, but excluding it. Okay, so this is saying the putter is valid. Everything from putter last to aligned end is poison. So the part of the union that we're not using is poison. Okay, this is correct. I was worried that we're like consuming 2 pointers worth, but we're only consuming 1. That's all good. I had to mentally create the diagram in my head. Okay, we're now done with annotate switch to large. Apply annotation. Parameter used to be called putter, now it's called first and gains top level const. This code goes away. We have new code here. This is not helping. Thanks, GitHub. I want to switch to side by side. What I really want is the thing that we have in our internal reveal tool where I can switch entirely to new code, but see only what's changed rather than just looking at the file as a whole. I dislike split mode, but I'll use it if I need to. Okay, too far down. Here we go. We just finished annotate switch to large. Okay, apply annotation. Const first. Okay, so old code goes away. Now we have. Note that capacity, old size, and new size do not include the null terminator. So const void star const end is first plus capacity plus 1. Okay. Old last is first plus the old size plus 1. These are, what are these? Value types. Why are they plus 1? Oh, because of the null terminator? The null terminator is a factor for the size. So I could imagine that, but why would we be doing this for capacity here?
Because our capacity is our actual capacity minus 1.
Okay, that's what I forgot. You can tell I've worked on. Yeah, it's an old representation choice before my time. So, okay, thanks for mentioning that. Okay, so that's all correct. Yeah, so whenever I see null terminator, I'm like, whoa, sirens, something could be wrong here. Context per bool, large string always ASAN aligned.
Null is spelled wrong there.
Oh, yeah, NULL. So NUL is the ASCII name for the null character, but if you spell it out as a word, it's reasonable to spell it out like this. The thing that would be wrong would be all capital null, because that's the macro for the null pointer constant. Null terminator like this, I think, is conventional. I don't think that's wrong. I guess you could have a different stylistic convention, I suppose. The one I'm allergic to is referring to null terminator as all capital null, which it's not. Okay, large string always ASAN aligned. It's context per bool. when the container allocation minimum alignment for our basic string is greater than or equal to ASAN granularity, okay? If const expr, large string always ASAN aligned, and small string always ASAN aligned, then hey, the stars have aligned. Old state, first valid ends at old last, and then the rest is poison. We're moving that to new last. Okay, good. First end, old last, new last, otherwise. Okay, this is just getting indented. Why is this not, no, it's not getting it. It's getting significantly changed. It's just not doing interline diffing. Okay. Otherwise, const auto aligned is to get ASAN aligned for send. The buffer must always have size greater than or equal to 9 bytes. So we'll always end at least one shadow memory section. Okay, so you have that guarantee that we talked about. Last must be less than or equal to than end. So fix up when aligned end is strictly less than underscore star underscore last. Okay. So old fixed, clamp to end, old last, new fixed, clamp to end, new last. Okay, old state. Here, these are actually contiguous lines. Just the narrow screen is messing things up. The valid boundary was at old fixed, aligned and poison, new state. These old state, new states are very nice to explain what the intention is. Okay, that's good. Now we have some helper macros. Everything after this is a lot easier. Once all the support machinery is defined, and I think we can actually go back to intra diffing. Reload. Okay, scroll. Okay, the macro, helper macros. No more ASAN string modify in taking 1 arg. Now we take 3 args. Stir old size, new size. Calls stir modify annotation old size, new size. We now have other macros switch to large, which will take our scary val base class. Call annotate switch to large or remove SSO annotation. Okay, these match the names. That seems reasonable. Otherwise, expands to nothing. We still have remove and create, but none of this modify or the single arg modify. Okay. So, is this merge damage? This looks like this is a change that Casey recently made, I thought.
Yeah, that must be merge damage.
Okay, I'll add a comment. I think a merge was incorrectly resolved here. Also, I'm not sure if you've merged with main. Please double check that you've merged with main and picked up. Let's annotate for the records what PR we're talking about. This was like a whole 7 days ago, so I've completely forgotten. That's not actually going to be useful. Let me look at X string. My memory is sort of timeless. I'm like, oh, we changed something there, and it could be 12 years ago, it could be 7 days ago, and I'll remember it the same, but I don't remember exactly what changed. Okay, so what is the history? It was Casey's miscellaneous cleanups. We created PRs almost simultaneously. Mine was various cleanups. His was miscellaneous cleanups. Finding some good stuff to clean up, but small enough that it didn't make sense to make separate PRs. Yeah, so here Casey said, okay, we're going to take Al. We're going to use it to construct the allocator in our compressed pair, but then we don't need to redundantly provide it to move construct from subster. That one can just use our allocator. We have a whole function for that. So this function doesn't take Al at all. So if you've merged with main, this should not be showing up as an edit. So yeah, something's gone interesting with the merge there. As an aside, I can use this opportunity to mention a tool which I really like, and I think I've mentioned in other code reviews. I know you're aware, but for our audience, if you're looking at our repo or any repo, if you've got Git installed, you can use git k, and that will launch, let me drag it over here, a graphical viewer of history. And this allows you to see what branch you're on, what commits you're looking at. Our main branch always has completely linear history. But it's possible to see merges and stuff. And there's other ways to get this info. There's other graphical viewers. You can do this on the command line with some graph arguments, but I like GitK. And it can be helpful to understand what you've merged recently. Okay, so we want to pick up 3178. Okay, double check that's the right citation. It is. Okay, stray damage. Let's see what's going on here. So we're moving the assignment of count down. That's fine. And then ASAN string create with this. Okay. I don't know if it's necessary to move the my size down. Was there a rationale for moving this assignment?
So everywhere else we have, I think everywhere else we have my res assigned first, count assigned second, or my size assigned second, ASAN string create third.
Ah.
So that's what the idea was there.
Okay. Big fan of following conventions within a single file. So thanks. And then we're moving up the ASAN string create before we start actually assigning to the stuff. That seems entirely reasonable. Okay. Here, what are we doing? Are we still within the same function? Nope, we're in construct from iter. So ASAN string remove this, remove any special annotations, switch to large. Misko, who worked extensively on string, says something's fishy here. At the end of the function, we call ASAN string create. Nicole replies, switch to large, creates a valid ASAN region inside the SSO buffer for the pointer because we're switching to large mode. And then ASAN string create creates a valid ASAN region in the large buffer. Okay. Yeah, trying to communicate complicated concepts in like 3 and 1 words is difficult, but this seems reasonable. I wonder if comments, like we've generally moved away from redundant comments and functions, but maybe explaining this in the actual functions would be useful. Did we have that? Where are they? This is apply annotation, switch to large, annotates exactly the pointer is valid. Okay, that summarizes what you said. Then what was the other one? Create, what does create call? Macro, sorry for scrolling. Create calls the existing create annotation. Okay, I think we've already got comments there. So this doesn't demand an extra comment. Okay. And then changing the arguments because modify is no longer taking a delta of size. You take the left size and new size, or you pass the left size and new size. Okay, let's make sure all these are actually correct. Interesting that right size was passed as a delta before. It's because we're concatenating. Yeah, we're concatenating. Okay, got it. I was also checking to see if some variables had become no longer necessary, but of course we're going to still need right size. Okay. So we are concatenating. If fits in left, take left's buffer. So old was left, new is new size. If here I'm assuming we're fits in right. Yeah, fits in right. If allocator is equal and fits in right, then we're starting with right size and becoming new size. And
I need to go. So
okay.
Thanks for the review.
Awesome. Thank you, Nicole. And I should probably finish up myself because we are at 5:26. Looks like the rest of the changes here to string are pretty minimal. So I will go ahead and submit partial comments. I'll come back and review the test code later, but I'll capture these comments here. This is looking very solid. So thank you for working on this extremely difficult problem and enabling string ASAN annotations, which will be a great feature. Cool. Bye, Nicole. And thank you for watching another VC Libraries Open Code review. We'll see you next time.